All right, this is our second video on 12.2. So we looked at arithmetic sequences, what they were, and kind of how they worked. So let's try this example. So give a recursive formula for the arithmetic sequence and find a formula for the nth term. So this one's a little different because they're giving you some other term other than the first one, and actually two of them. So we have the fourth term, that's 3, and the 20th term, that's 35. So what we're going to do is we're going to find out what that common difference is. And there's a few ways to do it, but the way I like the best is this. If you look at the worksheets that I did online, I did it a different way. So there's more than one way to do this, and just pick your favorite. So I'll do one way in the notes. The online worksheets have a different way. Just use whatever you want. So I know the fourth term and I know the 20th term. So there are 16 terms in between. So 16 terms from fourth to 20th. So my common difference is I'm going to take the two terms themselves and I'm going to subtract them. And then I'm going to divide it by how many terms there are from the 4th to the 20th. So I'm going to divide by the 16. And that'll come out to 2. And that's a quick, easy way to get the common difference. It's kind of, to me, I like it a little bit better. It's a little bit more straightforward and easier to calculate. So I know my common difference is 2. So what I want to do now is figure out the first term. I have the fourth one, but I want to go off of the first. So my first term, I'm going to start with the fourth term, the 3. And I got to subtract that common difference to get back to the first term. Well, how many times am I going to have to subtract 2 if I'm going to go from the fourth to the first? I'm going to have to subtract it 3 times. So take the D, multiply it by how many times you have to subtract it, and we come out with -3. So that is my first term. So then I'm going to jump back to the nth term, because now I know the D, I know the first term, so I can just use this. So -3 plus n minus 1 times that common difference of 2. So my nth term, just kind of multiplied out, would be 2n minus 5. Okay, let's go ahead and try that again, because I know some of you are going, what did he just do? Okay, so from my 8th to my 18th term, there's 10 terms. Right, because 18 minus 8 is 10. So take the terms themselves, the -96, minus off the 8th term, or minus off the 4, and I'm going to divide it by 10, and that comes out to -10, and that is my common difference. So to give me the next term, every single time I'm going to keep subtracting 10. So I need to figure out what the first term was. I have the 8th, but now I want to know, well, where did all of this start? So take the 8th term, so I'm going to take the 4, and I'm going to subtract off that common difference. And how many times am I going to have to subtract it to get from the 8th to the first? 7. And you can do it individually if you want, just like keep minusing off a -10 7 times, or just do it all at once. And you get a 74. So now you can get your nth term. and then just distribute. So 84 minus 10n. All right. So now we have the sum of the first n terms of an arithmetic sequence. So kind of like it's a summation, but for an arithmetic sequence, it's pretty simple. Just add up the first term and the last term, multiply by the number of terms there are, and then divide it by 2. So it's pretty simple to use. So on this one, from 1 to 80, that's 80 terms. And then your first term is 1, the last term is 80. And so you get a total of 3,240 by the time you add, divide, and multiply. Okay, let's look at this one. From 1 to 75, how many terms are there? Well, if we went 1, 2, 3, 4, 5, 6, 7, we did all of them, all the numbers from 1 to 75, that'd be 75 numbers. Well, we took out all of the evens. So essentially, we kind of took out like almost half, but not quite. It would be exactly half if this number was an even, but it's like we have one extra odd. So what you can do, if you just leave out the evens, or if you just leave out the odds sometimes, or just the evens, just add 1 to this number, so that'd be 76, cut it in half. So take this 75, add 1 to it, and then do 76 divided by 2. That give you 38. So there's 38 numbers, 38 odd numbers from 1 to 75. So 38 over 2. First number is 1. The last number is 75. So you have 19 times 76, which is 1,444. All right, part C. This one's a little trickier. You got to know how many terms are in there if you want to actually do this out. So we're going to use the nth term again. So an is equal to your first term plus n minus 1 times d. And I'm going to use this because I know the last term in there is negative 299. I know my first term is 7. Oops. I don't know n, so I'm going to leave it alone. And I can also figure out the d. So what are you doing to 7 to make it a 1? Well, you're adding negative 6. So that's your common difference. So now I can just solve this equation for n. So distribute, I keep doing that. Distribute the negative 6, and we get 13 minus 6n. So swing over the 13, divide by negative 6, and n comes out to equal 52. So now you have the number of terms. So 52 over 2 times 7, and your last term is negative 299. And if you work all this out, that's negative 7,592. And we'll go ahead and do part D since we're here. So part D, that's just the sum. And we have some formulas for that. So this one's really just kind of a review. So I can pull out the 1/3. And then the half will put in its own sum. So the 1/3 just stays. The n, that formula, would be the 80 times 81 all over 2. And then the half is just a half times the stop number of 80. So 1080 plus 40, or 1120. All right, so that is going to do it for section 12.2. And 12.3, we'll look at another type of sequence.